Welcome to The Explainer. You know that feeling of just smooth, effortless motion? Like a car gliding down the highway or an escalator just carrying you up. Well, today we're going to pull back the curtain on the simple but super powerful physics behind that exact feeling. It's called constant velocity.
Okay, so to get started, let's just forget about all the formulas and textbooks for a second. Seriously, I just want you to think about the world around you and how stuff moves.
And at first, you might be thinking, I can't really think of anything, but I promise you, this kind of smooth and steady motion, it is everywhere. Just think about your commute, or maybe the last time you were at a mall. We see it so often that our brains just kind of filter it out. It doesn't even register until we actually stop and decide to look for it.
Okay, so here's a really important point. In the real world, perfect, 100% constant motion, well, it's kind of a myth. You've always got things like friction or air resistance messing with it. But you know what? That's totally okay, because we can find tons of examples that get so close to perfect, and they're exactly what we need to really get this idea.
All right, so now that we've got a feel for this smooth, uniform kind of movement, let's give it its official name and lock down a super clear definition.
It's actually a really simple two-part rule. That's it, just two things. First, to have constant velocity, an object's speed has to be steady, right? No speeding up, no slowing down. And second, and this is just as important, its direction can't change either. It has to be moving in a perfectly straight line. Both things have to be true.
Okay, cool. So let's take that definition and turn it into like a field guide for spotting physics. Where can we actually see constant velocity out there in the wild?
This is so cool because it connects that abstract idea to stuff we see all the time. I mean, an escalator. It's the perfect example. It just moves, same speed, same direction, no drama. And a car with cruise control on a long, straight highway? Another fantastic real-world example of getting really close to constant velocity.
One of the best ways to really understand what something is to look at what it isn't. It's kind of a life hack, right? So let's flip the coin here and check out motion that's the total opposite, motion that's always changing.
And this just nails the difference, doesn't it? On one side, you've got that smooth, predictable, almost calming glide of an escalator. And on the other, a car in city traffic. It's jerky, it's unpredictable, you're speeding up, slamming on the brakes, stopping, starting. That is what changing velocity feels like.
So let's think through these. A runner, they're going to get tired, right? They'll slow down. Boom, speed changes. Or what about throwing a ball? Gravity grabs it and pulls it down in an arc, so not only is its speed changing, but its direction is changing every single second. So here's the big rule to remember. If the speed or the direction changes, even a little bit, it's game over for constant velocity.
Okay, so what if we tried to, draw a picture of this motion? Is there a way we can actually see constant velocity on a graph?
It's a cool idea, right? Every single type of motion leaves behind a unique pattern when you graph it. It's like its own little fingerprint. So, what does the fingerprint for constant velocity look like?
And there it is. It's just a straight line on a position versus time graph. That's the signature, a perfectly straight, slanted line. And if you think about it, that makes total sense, right? It's the visual story of an object that's covering the exact same amount of ground in every tick of the clock.
And check this out. These three simple rules are basically your toolkit for reading these graphs like a total pro. Rule 1. See a straight, slanted line? You know instantly. That's constant velocity. Rule 2. If the line is completely flat, well, the object's not going anywhere. It's just standing still. And Rule 3. The steeper that line gets, the faster the object is moving. Simple as that.
Okay, so after all that, you might be wondering, why does this even matter? What's the big deal about a straight line on a graph? It's a fair question.
Look, this isn't just about memorizing some definition for a pop quiz. Not at all. It's about you being able to finish this sentence for yourself. It's about getting a whole new way of seeing, a new framework for understanding all the movement that's happening around you, like right now.
So what this all really means is you've just learned how to decode a fundamental pattern of the universe. I'm serious. This isn't just a fun little science fact. This is the foundation. It's the baseline, the normal, that we measure all other kinds of motion against. Like speeding up or turning a corner. What used to just look like stuff moving around now has a hidden order that you can actually see.
And honestly, that's the real takeaway here. Now that you know exactly what to look for, that smooth, steady, straight line movement,
I promise you, you're going to start seeing it absolutely everywhere. So, I'll leave you with this question. What's the first thing you're going to spot today?